Welcome to an ode to firmware design. The chords we will be playing today are some C, some get crazy with G7, a little F. It's probably going to be out of tune. And to get on with the show, we'll get it going. No, that's enough. Okay, let's talk about firmware. But what is firmware? Also, I tried to stick with the Renaissance theme, but it's really hard to find the exact art and memes to really portray my meaning, so I had to improvise. So anyway, in 1967, a man named Asher Oppler coined the term firmware as an intermediary between hardware and software. Also, I couldn't find a picture of him, so you get a stick figure. A little improvisation. This totally makes sense, because if something is not soft, but it's also not hard, then surely it's firm. Right? Sorry, did not give warning for that, but seriously, it's less about a literal developer. Oh shoot, I hit a button. It's less about a literal definition and more about defining the area of design concern. For example, much of our user interaction today is via websites and apps, but the developer making these instructions, the concern is almost entirely in the software, because the software is almost always delivered from a central server or the cloud, and delivers the content to the device via some internet connection, some socket, some transport layer of some sort. The developer in this case really doesn't have to think about the how in terms of hardware. The server hardware, the utility, the VMs, it's all defined for them. They just kind of have to pick the right ones. The tablet or phone gives a generalized SDK for how to run the software, but the app is compiled with the hardware instructions without the developer really having to deal with that layer or think about it. So really, most of the limiting considerations are a few parameters like, how fast is the internet going to be for this service? And is my app in a memory hog and I need lots to run well? And maybe if we K8 deploy the sucker or something really cool with Rust, I don't know, those are buzzwords. And maybe they might have to worry about getting this thing gaining sentience and value to destroy all humankind. But that sounds like a future them problem. So with firmware, we could really consider it to be more like a software plus. It's still software, but with the intent for low-level control of hardware functions, for device-specific hardware, or as an abstraction layer for a higher-level software like operating systems and the like. And as another perspective, CPUs are really just fancy bits of sand that we make think for us, but we still tell them how to think in some way. But really, as developers, we're really good at deciding the what of a program has to do for us. But the how is defined in a lot of ways. For example, like virtual machines and interpreters, it doesn't go automatically. Pre-compiled instruction sets or ASTs, more fun words. But with hardware, like everyday use electronics or embedded devices, the how gets a bit trickier. For example, let's look at a super simple thermostat. When the sun comes out and really heats things up, we want it to trigger a fan or AC to help cool us down, right? And the what and when of this is really simple. We're very good at this. If the temperature is over the perfect 72 degrees Fahrenheit or 22.222 repeating Celsius for the other side of the world, I guess, turn the fan on. If it's not, turn the fan off and let it heat up a bit to get to that temperature. But how do you even control the fan? In simplest terms, the fan control is essentially a button or a switch, and when you push the button to close the circuit, the fan would turn on. Except in our thermostat, no one is waving around to press the button, and instead we have a processor. Instead of a button, we might have like a relay, and a relay has instructions on how to activate it, and the processor has hardware capability that supports the requirements for this relay, such as being able to activate some sort of pins, high or low. And now we can tell our processor to do the required action and see the fan turn on, because our processor can set a pin high and our trigger knows to close if the pin's high, et cetera, et cetera. And this, in a super simple form, is firmware design, the combination of software with the expected hardware interaction layer. And now to address the elephant in the room. But why, John, are we talking about firmware if I never work with hardware? It's a great question. And it's because I think you should. Or to elaborate, I think the world is moving to be in a more connected state. Smart locks, smart cameras, doorbells, toothbrushes, even ovens. And there are smart devices which are questionable at best. But being smart is only a part of the story. We also want easy interaction, especially with our voice via smart assistants, and ultimately to that Jarvis level dream where we can augment a human experience effortlessly between us and machine, especially, to prevent bad ideas. But seriously, AI, machine learning, mechanical autonomy are all breaking ground, and my prediction is that embedded systems are on the rise because that's the layer of which we need to interact at that dream level. Firmware and firmware delivery is going to be a crucial role here, and there's lots of amazing tooling and resources to aid in firmware development. So you and I can build our systems, bring our ideas to life, and in most cases, the biggest hurdle is yourself, trying to stop you from venturing into the unknown or making the new feel scary. So without further ado, actually, I want to play some music for this. This is John's opinionated ideas on firmware design for newcomers. And veterans are also welcome. Almost all of this is going to be referencing patterns using Elixir and nerves, and I know this is like a huge shocker if you even know who I am. And if you don't know what nerves is, it's essentially a bunch of cool tooling to run Elixir in an embedded sense with a small firmware footprint and official support on easy-to-get consumer hardware like Raspberry Pi. Or this used to be easy to get. It's a different story now. Hashtag pandemic. Or what is it, Pandy? Yeah. Though I will try to keep things a little generic because technically if you install Elixir on another supported OS on these devices, like Raspberry Pi OS, then that's firmware too, so you're in business. It's totally cool. So to get things rolling, let's first discuss the Poncho project. Has anybody heard this term? Like 5 hands? Okay. Well, buckle up, I guess. You're in for a lesson. Way back in 2017, originally coined by Justin Schneck and written up by Greg, as I've heard this trip, mostly as a joke, the problem at hand was that umbrella projects were becoming super hot. And the concept was that you'd have a root level directory with configuration and apps and directories. You would put your Elixir libraries within this context. But one of the big hiccups with this is that all of your special tooling, your configuration for hardware concerns are in this firmware directory. This is where you would typically bring in nerves, dependency, or type tooling. But an umbrella project wants everything to be used and called from the root of in here and has a lot of conveniences, maybe we should call them magic, in managing these dependencies in this tree or this directory structure. And so now you have 2 pieces of tooling unnecessarily fighting for control. And in fact, if you try this, you'll get helpful warnings, and you can follow all the warnings to eventually get the umbrella project working with nerves. But by putting the right config values in place and setting up OTP release structures and yada, yada, yada. But really what we're after in this is the structural idea as more of a protection from sides rather than from the top down. And mainly having a root structure as an organizational tactic to organize different libraries that you might need to use, but the control would stay within firmware. You'd reference these things using simple path dependencies and to get right what you need right from the development host. And I know exactly what many of you are thinking. A lot of you super performant driven developers. Isn't that a monorepo? Yeah. I don't even know what the general consensus is anymore, but it used to be that it was super bad. You don't want to do this. This is a bad design choice and really frowned upon. But yes, it is. And what if I told you it's also a microservice? Yeah? That's what I wanted. But really, I don't even want you to think about any of that because it's totally different. This Poncho, umbrella, whatever, however you have it organized, it's all bundled under a single firmware, one source. Call it Mono or Uno or whatever. It's all destined to run together, and this is more of an organizational tactic but run on a single device. And all these pieces of the firmware almost always live independently controlled on this hardware, especially with the Beam and OTP, and we get all this process and concurrency, and we can really run asynchronously. But each will require communication with each other per diem, almost like a microservice. Except it's not some HTTP API between servers, it's simple messaging between processes or functions managed by explicitly defined libraries. But actually, the point that I'm trying to make is to just abandon all preconceptions and think differently about the firmware design. And my very opinionated take is to first think, where is the concern? From a very high level, it doesn't really matter how you have things organized, whether it's Poncho or Umbrella, or just even the scope, everything within your firmware library. As long as you think about the very first concern, that this will go into a single firmware, and that firmware will go to interact with hardware or even on many devices. And so now that the initial design concern is out of the way, when you're thinking about firmware to many, let's talk about the next step, which is keep as much on the host as possible, or CamoHap, as I like to call it, for short. And again, this is totally confusing because I literally just talked a whole bunch about designing software with the mentality that's going on hardware. But really, I'm still referring to the concern during development, and I just liked this catchy phrase. I can't think of a better one, so let me explain what I really mean. With the need for software and hardware, we know that firmware is the bridge between the two. It's the glue, the connection when you're building for this set. But one tends to develop more with hardware in mind as their main concern. Because, I don't know, is it shiny and new? It just is the pattern, I guess, that I see. Which means in the development cycle, writing a bit of code on your host and burning it to the drive, and putting it back into the device and connecting the sensor and discovering it totally doesn't work. So you pop that SD card back out, delete all that code, try it again, and this cycle can really repeat when trying new things, new hardware, new ideas that you may not have even ventured for. And this is a really slow process, or it can be. And you might be tempted to think that you have to do it this way. Because it's hardware, you have to mess with it, interact with it, right? Especially when you see stuff like this, where some of these dependencies are segregated between target and host. It really drives that feeling that any small change needs to be put on the device immediately to test and verify. But I will venture to say that there is another way. And it's totally counterintuitive because it's just don't do that. Instead, let these types of dependencies, if they can, or if you have control, exist on the host. I know we're getting really deep in the rabbit hole here. This is totally bonkers, but I swear it'll get better. How many of you have heard the term hardware abstraction layer? This is actually more than has heard of Poncho projects, so that's cool. Okay, or HAL for short. The idea is that you abstract out hardware-specific resources into interfaces and routines so you can easily swap out backends with hardware. And it's probably arguably a lot lower level. And my wild idea is that you do this with your firmware to an extent. I've more or less been referring to it as a dumb HAL. Because you're not really changing the backend per se, but you're more so specifying implementation for a target. And to show you what I mean, let's say our little thermostat needs to read a temperature sensor via I2C. By writing to a register at a specific address, reading run byteback, it's a pretty typical common, or pattern, not common. This is what the code might look like with, this is totally made up code and addresses, so don't copy paste this. But even though I set circuits I2C to be available on the host, like I just said, it will totally crash and burn if you run this on the host, if you have code that makes those calls. But if you instead take a HAL-like approach, you could separate concerns here by having a target level implementation, which delegates appropriate functionality to the hardware when needed, and a host level implementation, which are here just basically return stubbed dummy data, mocking out, whatever you want to call it, just for the sake of returning, in my case. Then maybe add some glue code to your config that will define which abstraction to use in which case, especially based on the target. And then you can just use your singular abstracted out implementation with the sensible default and use that when making the needed function calls. And now you have sort of some separation of concerns, but you can still do the same sort of development on targeted hosts. Or as another idea, you could just conditionally define your abstraction and not deal with configs at all. But I consider this level semantics and totally up to the developer to decide what you're looking at. I don't particularly care for writing conditionally defined code, but you do you. So now yet again, continuing down this hall, you're probably thinking, okay, John, your host Hal is just stubbing data and mocking it, and that's bad. And there's not even mocks and explicit contracts like Jose and Connor and probably lots of others have written about in this realm. How dare you? And my hot take here is, it doesn't really matter, usually. Let's put that asterisk there. You see, these devices will have specifications on how to interface with them at that hardware layer. And it's frequently via well-defined protocols like I2C, SPI, UART. And these things underwent lots of testing at the factory. These products at the manufacturing level at a good manufacturing level, go through lots of scrutiny. So I really, really trust that if I send them the proper input defined by their specification, that I will also get the expected output defined by their specification. And the actual implementation of these hardware via these protocols, believe it or not, is outside of my development concern. That's the concern of the manufacturers or the library that provides the functionality to make that communication call. And that was someone else's job to make sure they're tested and perform. It's totally cool. And if not, I totally want the hardware to fail and become known as faulty. Absolutely blow up on the device because I don't want to troubleshoot broken hardware from unit tests. I don't even know how you do that. But basically, whatever it takes to make my host development easier when hardware is involved, I'm pretty okay with. But for the cynics out there still not convinced and demand an easy end-to-end test, here's another idea. Erlang distribution. It's a cool buzzword. You know what I'm talking about. For example, make your abstraction connect to the remote device as a node and send the hardware request to the physical device, getting back the actual sensor data on your host, using this for development, testing, whatever. I think this is a totally useful tool that you can have and absolutely valid. I will validate anybody that wants to do this and gets backlash. And if all else fails, you can also just remotely connect to your device and copy pasta some quick code right into IEX for quick testing. And I'm not ashamed to say that I use this probably 70% of the time. So to recap, CamoHap, as a development design concern, it just makes you really think about the interactions, the behaviors, the how of the situation from a familiar development setup and with much more confidence ahead of time before actually putting it on the device. So when you're ready for that step, it runs much smoother, everything goes along, and it just works. And if it doesn't, well, at least now you have a crazy good host development setup to grab some error reports, bad data, whatever, and attempt to replicate locally and add some tests maybe with the newly discovered bad data and have to dig in. And you could dig in on the device again later once you have more confidence. Now, speaking of which, let's shift gears a bit and cruise to talk about something I know that you're all dying to listen to. Testing. Are there any TDD lovers out here? We got a lot of hands? Yeah, I knew you guys would be here. Just waiting for this. Anyway, what I notice with many people coming to the nerves, or firmware development in general, is that we drift towards hardware so much and away from host testing. And it just gets left in the dust. And all I can really say again is don't do that. No matter the firmware setup, treat it like you would any other project in design, in any other system you're working with, to be almost as applicable on host as it is on target, using some of the ideas previously talked about. All you TD and testing nerds will know way more than me in the actual realms of what to do in testing. There are tons of talks about it, so I'm not going to get real into the weeds there. But the main point I want to say around testing with firmware and hardware is try your best to keep tests functional. and concern yourself more with the expected inputs and outputs of these well-defined behaviors before you actually get to putting that code on there. And then you can test scenarios rather than focusing on expecting a request from I2C sensor back giving you data during your unit test. And because I said previously that these devices are unwaveringly loyal in feeding you back data, it has to be completely kaput not to respond. And as an example, let's test the behavior of our super simple thermostat, where we need to react to an async temperature reading from the fan, because temperature is always changing, which I can more or less replicate in this simple form by sending my thermostat process the same message it would get from my sensor, assuming real hardware was connected. And then I can assert my behavior functions, and as expected before and after the event, I can kind of really see that the change was dictated. And the caveat here is that this is a really simple example. Things may get totally more complex, but this is really common behavior with hardware, to integrate with the device and deal with asynchronous data communicating back to you. In fact, Nervous is a really good tool set for doing that sort of sensor data aggregation together. And focusing firmware design on data and hardware expectations can really pay out in aiding development and testing your experience. So other final steps as we wind down are allow design to support mixed tests and an interactive IDX session. This can potentially require a tidbit of setup and usually gets you going down the right track. You might fumble a bit in the beginning trying to get the right pieces in place, but it totally pays off. Focus on functional designs and tests, like we were just talking about. When the hardware might need to be evolved, test the expected inputs, outputs. Let the specific implementation live where it isn't supported, like host or target. And remember, mocks and stubs can be okay of these hardware interactions, because again, the protocol is defined. We don't care what comes back. We just care that we send it the right data and we can react to the good data. And even though I bashed on them a bit, explicit contracts, they're good too. If you have control of the library and that's your jam, again, you do you. So just remember, hardware can be scary, but you totally got this. A little bit of practice, time, experimentation, and you'll be making your own gadgets and gizmos in no time. Yeah.